Hello students, welcome to Sarasa classes. Now in this particular section we will be discussing synthesis of acid chlorides. So we are assigning this as RCOCl. Now it is worthwhile to mention that formation of acid chlorides is a little bit of a challenge because it is involving the substitution reaction that is introducing a beta leaving group inside the molecule. So what you are trying to do is, suppose you have a R C double bond OH, and from here you are trying to make RCOCl. Now if you compare the leaving group ability, you are sure that OH is a bad leaving group and Cl is a good leaving group. But whatever we have been discussing is it is better to introduce or easier to introduce a bad leaving group and removing a good leaving group. Okay, that is how the reaction goes for acid derivatives. So what is the way out of this problem? So for converting a acid to a acid chloride, we have to think of a way in which we are converting the OH into a better leaving group. So how do we do it? So basically a reaction of a carboxylic acid with a reagent of thionyl chloride, that is SOCl2, it helps us to overcome this problem. Okay, how? By first converting the OH group into an excellent leaving group, and that can be replaced by Cl. So what are we using? We are using SOCl2, and we are also using certain amount of catalytic base, and this conversion is taking place. So what is the mechanism that is involved over here? So initially what happens, we have the carboxylic acid and we have the SOCl2. So this particular OH will make an attack over here that opens up to give you this type of an intermediate. Now what happens in the next step is this comes back and that goes away. Also at the same time, one can think of the proton being cleaved off the molecule. So this is what has been formed over here. Now in this particular step, one can think that the chloride that was released will make a nucleophilic attack over here that opens up, and we have this intermediate being formed over here. Okay, which is our CTI. Okay, and now elimination will take place. Okay, and that gives you the acid chloride. SO2 as a gas is removed away under the reaction conditions, and so is HCl. So because the gas products are formed as the byproducts, so the reaction under the Lee-Sartler principle is driven forward, and that is how we achieve the conversion of a acid chloride to acid chloride. Now in the next section we will be discussing the synthesis of anhydrides, which is RCO2COR. Okay. Now out here, anhydrides are molecules that contain a highly electrophilic center bearing a very good leaving group. So this is the highly electrophilic center and which is having a very good leaving group, which is obviously we are saying this one, and they can be used to synthesize many organic molecules from them. Now as the name itself says, it is an anhydride, so it means it can be formed by dehydration of the carboxylic acid, which means the oxygen, that is OH, of one carboxylic acid molecule acts as a nucleophile attacking the carbonyl carbon of another molecule. Now here the acyl substitution which is our addition elimination reaction results in loss of the water molecule. So how is this happening? We can think of whatever we have written in a diagrammatic representation. These are the two carboxylic acid groups. We are heating them in presence of a drying agent, which is our P2O5, or one can use acetic anhydride. Okay, and that will lead to the formation of a symmetrical acid anhydride, which is this. Now heat here basically distills of the water and push the equilibrium forward. Okay, and any amount of water that will be left will be taken up by this drying agent over here. So mechanistically, what is happening over here? We have a R double bond O OH, and suppose this is protonated, that means it is activated. This is our electrophilic carbon over here. This is our another acid molecule where the oxygen is acting as a nucleophile, so it is acting over, making attack over here. That opens up. All right. Now that is coming back, leading to the removal of water. Okay. So here water is a living group, and it is never going to be reversible because it is irreversible because we are maintaining reaction conditions where side product is removed. Okay, that is how we are taking the reaction forward, and so eventually we are going to get over here our anhydride. Now if we wanted to make mixed anhydrides, what should be our starting materials? So here to make a mixed anhydride, basically we will take a acid chloride and a carboxylic acid. We will take pyridine to remove the catalytic amount of pyridine to remove the side product HCl that will be formed in the reaction. Okay, and if we heat this, then out of this we will be getting our mixed acid anhydride, where the role of the pyridine is to react with the HCl and drive the reaction in the forward direction. Okay, so that is the role of the pyridine out here. Okay, now in the next portion we will